Really pleased to introduce Beth Gilhespy. Beth has been a conservation professional for over 30 years. In March of 2024, this year, she's just become the CEO of the Escarpment Biosphere Conservancy, which is an organization dedicated to land preservation. So congratulations, Beth, that's wonderful. Prior to this, she was executive director of the Toronto Zoo Wildlife Conservancy from 2019 to 2024, which is an organization that secures the funds for the Toronto Zoo endangered species conservation programs. Wow, that's great. Between 2004 and 2018, Beth was CEO of the Bruce Trail Conservancy, where she oversaw the preservation of more than 6,500 acres of land along the Niagara Escarpment. Beth has also served on the Niagara Escarpment Commission from 2017 to 2019. And prior to her work at the Bruce Trail Conservancy, she worked for 15 years as a consultant, specializing in the environmental impact of toxic chemicals. She holds a Bachelor of Science and a Master of Science degree in Physical Geography and Geology from the University of Guelph. On a personal level, she is an avid hiker, traveler, fossil collector, that's cool, and self-professed landscape fanatic. Love that. And when not enjoying her time on the land, she is currently writing her second book on the geology of the Niagara Escarpment. And we just Googled it and found out that your first book was called Walking Through Time. So I'm really pleased to let Beth take over the floor.
Thank you for that very lovely introduction. And can you hear me all right at this level?
Yes. Everybody in the room good?
Okay, good.
Yeah.
Great to hear it. If there's ever any issue, just let me know. I want to thank you for inviting me. You guys got ahead of the curve, right? Beth is our new CEO starting in March 4th. And Beth, would you come and do a talk for us? So well done you. So I'm really, really pleased to be here tonight. Geology is a passion of mine. I have only done it professionally for one summer with the Ontario Geological Survey. Otherwise, it's been my hobby and my passion. Now, I have to say that it has intersected really nicely with my professional career, especially with the Bruce Trail Conservancy and now with the Escarpment Biosphere Conservancy. But it is something that I love, and I did write a book recently. I'm writing another one, and who knows where that will go. But one of the things I really love is talking about geology to people. And I think that land is a beautiful thing, and I can go out into a scruffy field and find magic there, because that scruffy field was once the bottom of a tropical sea 400 million years ago, and I find it really, really compelling. Of course, beautiful landscapes really help as well. So I'm delighted to be talking to you today about geology of the Niagara Escarpment. And I have to say, I have done a presentation like this on the geology of the Niagara Escarpment, I gotta say, maybe 50 times. I mean, a lot. And I can kind of go anywhere on the Niagara Escarpment on the mainland and sort of stand there and close my eyes and talk all about it, which is great. But now I find myself in new climes, new areas. Manitoulin Island. Now, yes, it's part of the Niagara Escarpment, but it's different, and it's delightfully different. So I'm going to talk a little bit about how it's different tonight. And you know, it's a complicated area geologically, and I'm going to focus in on a few things. And then I'm going to extend an invitation to you, because I'd really love to come up and explore Manitoulin Island, which I don't know very well. I'd like to explore it with a bunch of people who love it and love the land, and we can share some knowledge with each other. So with that, I'm going to get started. Niagara Escarpment, a natural masterpiece, 450 million years in the making, and I'm just really happy to be here. So let's get started. Of course, I've got to figure out what I'm doing. There we are. So you are here. You're at that green dot at the north end of my screen, and you know where you are. But I usually do this to orient to people who are perhaps less aware of the Niagara Escarpment and where they may have found it as they moved around, particularly southern Ontario. So if you've been to Tobermory and you've gone to Flower Pot Island and seen the flower pots, you've seen parts of the Niagara Escarpment. You may have gone skiing at Blue Mountains, or you've driven through the Beaver Valley, which is really lovely, and seen the Niagara Escarpment. If you're lucky enough like me to drive from Guelph to Toronto, a few or several days a week, depending on the week, you will have passed through the Niagara Escarpment, through a gap in the escarpment on the 401 at Kelso, which is just near Milton. And this passage is a natural gap in the escarpment that was used by caribou as the glaciers had retreated from the area. Caribou moved in, and this is one of their migration routes, which I find fascinating. I can go very slowly at that location because there's always a traffic jam, and I can think a lot about the caribou and the geology. You might have been down in Niagara area and gone to some of the wineries and the fruit trees, and there's a microclimate created there because of the escarpment helping buffer some of the winds and creating these little hot pockets. So of course, the ultimate is Niagara Falls, and people, the Niagara Escarpment, they know it must have something to do with Niagara. The escarpment is actually crosses the river several kilometers downstream at Queenston Heights. However, the falls themselves have worn back over the last 8, 10, 12,000 years to its current location. But Niagara Falls is falling over the Niagara Escarpment, fundamentally. It's just the waterfall has worked its way back over time. So I think that most people I speak with know the Niagara Escarpment. You guys will know it more acutely because you're on Manitoulin Island and you bump into it all the time. But most people have encountered it in their lives somewhere. So when I talk about the escarpment, and I'm especially happy to be talking to people on Manitoulin Island today because the escarpment is not a static Southern Ontario thing. Certainly the regulations around it, Niagara Escarpment Plan and things like that, are in Southern Ontario only. But the escarpment edge itself follows a really beautiful arc all the way around up the Bruce Peninsula of Southern Ontario, through Manitoulin Island, curves around down into Lake Michigan. It comes down a peninsula called the Dore Peninsula, which is sort of the mirror image of our Saugeen Bruce Peninsula. And then it disappears in the bottom under a lot of glacial till, because when those glaciers were melting, they had reached sort of that area of Ohio and then just left a whole bunch of dirt. So we have hundreds and hundreds of feet of glacial till covering up the escarpment. Now I want you to look at something on this little diagram before we move on. Have a look at what happens to the escarpment when it's between Lake Erie and Lake Ontario, and how it takes a sort of a right turn, because we're going to get to that in a second. I used to wonder why the escarpment was drawn as a lovely circle and then this sort of thing spinning off to the in an east-west direction, and there's a reason for that, but we'll get to that in a second. So we have to go back a long way to talk about the Niagara Escarpment, and a really long way. And the escarpment, I call my first book, well, actually the series of books, is Walking Through Time. When we walk on the land, we are walking through time. We're walking through many millions of years of time, in fact. And when we talk about the escarpment, we can go back about 450 million years. We have all these little bits of continent floating around on the Earth, with the plate tectonics theory of plates of continents moving around, with magma sort of driving that movement from below. You can see the arrow sort of shows, and the circle sort of shows where we are today. But we had this continent called Laurentia, a little bit like North America is now, except there was no Western Cordillera on it. There were no Rocky Mountains or anything like that. That came on a lot later. And you can also see that it is, in this image, straddling the equator. And in fact, the area where we are, even Southern Ontario, Manitoulin Island, that area was at about 10 degrees south of the equator 450 million years ago. So it was tropical. And most of the land, in fact, we go to the next slide, most of the land was underwater. So this is the continent with the diagram of where it is today. And you can see in the Ordovician, which is just the name of a major period of time in geological history, and then we have the Silurian, you can see that most of the continent that would become North America was underwater, and it was on its side, and it was straddling the equator. So it didn't quite look like it does today, but usually when I talk about the continent, I talk about it in a present day sense, that it's aligned north-south. But it certainly wasn't in those days. But what we did have were pieces of continent that were sort of between us and Africa, between us and Europe. They were being pushed by those major continents into what would become North America. And they were forcing up a very massive mountain range, really big mountain range. And when I say big, I mean, Himalayan size, and in fact, larger than Himalayas. The next slide, actually, I just wanted to point this book out. This is a fantastic book, and this came out in 2006. I know Peter Russell quite well, one of the authors. Lovely man. He's a professor at University of Waterloo. I live in Guelph. I'm not that far away. And we're both members of the local Rock and Mineral Club. And if that isn't the nerdiest thing you've heard tonight, then I don't know what is. But we have a lot of fun talking about rocks and minerals and fossils and things like that. But it's a really, really great book. And so that diagram I just showed you was adapted from this book. And this is just a wonderful resource, and I'm really looking forward to exploring more of Manitoulin with this in one pocket. And I'll show you another book I want to have in my other pocket. So that's just a little bit of a diversion. That diagram was adapted from this book. But here we go. Here's an example. I love this diagram. I saw this diagram in Lake Louise at a Geology Interpretive Center in Lake Louise. If you've been there, you might have been in this little building. And you can see the present day Appalachians are the darkest green at the bottom. And, we think of the Appalachians, they're not like massive mountains, but they're nice, big mountains, right? Then we have the Canadian Rockies, which are a little bit bigger. Then we have the present day Himalayas. And then we have those early Appalachian mountains. And they were very, very large, much higher than the present day Himalayas. So the Appalachians are the worn down remains of a very, very mighty mountain range. And what was happening off this mountain range, there were big rivers spilling into that shallow continental sea that was covering our area and other areas. And it was bringing sediments down from the mountains, a lot like what's happening today in the Ganges, as it pulls materials out of the Himalayas and then spills them into the Indian Ocean. We had the same kind of things. We had mud coming into the sea. We had sand coming in. We had times of calm and quiet where coral reefs would develop that would turn to limestone, that would turn to something we call dolostone. So we had lots of different layers of rock being deposited into this shallow sea because of this massive mountain range. We call so if you can imagine it, you saw the map earlier of North America, most of it being covered by water, but it's not level underwater, right? There's lots of pockets and there's high grounds, just like there is on dry land. And one of the pockets that we had in this area was called the Michigan Basin. And it was a depression in the basement rock, that lovely Canadian Shield rock, Precambrian rock. It was a depression, and the sediments were spilling into that depression and filling it up over time. And, the Niagara Escarpment is basically the edge of that ancient circular basin, the Michigan Basin. Now, why does it sort of spin off into the east-west direction is because there's another basin actually between the Michigan Basin and that rising set of mountains. It's called the Appalachian Basin. It's also called the Allegheny Basin, depends on what you read. But it actually, and I'm going to show you a diagram in a minute, but it actually had its leading edge roughly following the long axis of Lake Erie and Lake Ontario. And that's why you have this sort of shift in direction of the escarpment. Now, all of this was underwater, and the rock layers were roughly the same, but you just had a slightly different configuration of the landscape onto which these rocks were being deposited. So you get a little bit of a different form. You're also a lot closer to the source of all these sediments coming in from these mountains. So you get lots and lots more layers. When I go down to Niagara, it blows my mind, all the different rock layers. I come up to the Owen Sound area and I go, great, there are 6 layers. I can remember 6 layers. Manitoulin is a whole other ballgame, and we'll get to that in a second. So we had materials filling this basin for about 200 million years. And then we had the sea that was inhabiting the Michigan Basin, the Appalachian Basin, dried up, and we had that long period of erosion starting. But basically, our Niagara Escarpment is the edge of mostly the Michigan Basin, a little bit of the Appalachian or Allegheny Basin. This diagram might help a little bit better to show you how we have these two basins. They're sort of hydrologically connected at the surface, but under water, they are 2 pockets and, collected slightly different materials. But it's very important. Now, Manitoulin Island is solely at the edge of the Michigan Basin, so you don't have all that Appalachian Basin stuff to worry about. But it's good for context because the escarpment is not homogeneous. There are lots of different rock layers. There are also some rock layers that are consistent throughout it, so we'll talk about those as well. There's our basin, there's our Appalachian Basin, and here we go. So this is actually the layers of rock that I find in the Owen Sound area. And when you see the word dolostone, Dolostone is basically a limestone that has been altered with the presence of magnesium. Magnesium would have been in the seawater as the rock was forming, and it converts the limestone into what's called dolostone. So limestone is calcium carbonate, dolostone is calcium magnesium carbonate. And it's a slightly harder rock. I'm particular about calling it dolostone as opposed to limestone because it's dolostone and not limestone. In the mainland, if you will, of the Niagara Escarpment, there is no limestone. And it's called limestone all the time, particularly by quarry companies. But in fact, it's all dolostone. Now on Manitoulin, you have limestone. So we'll get to that in a second. So that's an Owen Sound, nice and super easy. Then I go to, what's this, Hamilton area, and I got a few more layers in there because remember, it's closer to the source of all those materials that are spilling into this basin and filling it up and creating hard rock. And then if you go down to Niagara, you have even more. So that's just a sort of an example of the farther you get away from the source, the easier it gets until you get to Manitoulin Island. So this is Manitoulin Island. Wow, there's a lot going on in Manitoulin Island. And in fact, if you can see my cursor, which I hope you can, our Niagara Escarpment starts at where it says sort of 80 to 100 meters here. That is where the base of the escarpment is on the mainland and on the Bruce Peninsula. And we have the rocks going up to where that blue, it says Niagara Escarpment Cuesta. But technically in Southern Ontario, all of these layers below roughly sort of this area here, everything below that is not considered part of the Niagara Escarpment. And the reason is that in Southern Ontario, these layers are much farther apart. And let me see if I can explain that a little bit to you. So here's the Southern Ontario view, and you've got a little bit of Manitoulin at the top, which is great. As you can see with this diagram, the rock layers are the youngest to the west and the oldest to the east. Now, why would that be, right? If the layers are all stacking on top of each other, why don't we have all one layer at the top, all of one age? The reason that we have this almost like a fan, it's almost like taking pages of a book and just sort of fanning them and they sort of spread out a little bit. The reason we have that is that as these rocks are being deposited, the center of the Michigan Basin was being drawn down from tectonic movement or the weight of the rock above it or both. It was being drawn down. So you got a slight little tilt to the rock. And that tilt is something you can see. You can see it on Manitoulin because the rock is the same layer of rock is at the shoreline on the south side of Manitoulin Island, and it's up high as you go north. And it's the same on the Bruce Peninsula. The Bruce Peninsula is tilted. The rock on the east side is very high. You get lovely big cliffs. On the west side, it is right at, in fact, it's already disappeared below the shoreline. So this is a really important factor when in Southern Ontario, when they talk about the Niagara Escarpment, they talk about mostly the Silurian rock layers, which is about 444 million years ago, with a little bit below that, a layer called the Queenston Shale, but that's it. You don't go below that. And because the other layers are quite far away and they have less of a concern. Toronto is sitting on top of Ordovician rock. It is not, it doesn't have the same sort of geological features that you see. You don't have nice big scarps and things like that. But what happens on Manitoulin Island is that everything is compressed. We don't have these long spaced out areas of Silurian rock and then Ordovician rock. We have it all nicely close together. You go from the Silurian era to the Ordovician back in time and then to the Precambrian. Like it's great. You have this wonderful sequence, all nice and tightly close together, which I think is wonderful. Let me see if I can explain it a little bit better. Having a bit of trouble. There we go. So just another diagram. I'm not sure if this helps much, but the top diagram is showing Southern Ontario. We're sort of talking London, Ontario on the left and Kingston, Ontario on the right. And you can see all of these layers are dipping down. They're dipping and they've been sort of sheared off at the top, eroded at the top, so that you can sort of spread these rock layers out over the landscape. And they spread really, really wide. Right. Whereas on Manitoulin Island, it's much, much shorter. You can see it on the right-hand side there at the bottom. You have a fairly compressed from Silurian rock to Ordovician rock to the Channel, and then you're in the La Cloche, which are the Precambrian rocks. So that's a delightful thing because it means you can get more geology closer together. So I'm excited by that opportunity. So here's a nice, simple geology map of Manitoulin Island. And I'm going to kind of talk about some of these layers in three major chunks. From the oldest rock that is not Precambrian and Canadian Shield, the oldest what we call Paleozoic or sedimentary rock on Manitoulin Island are the Georgian Bay Formation and older rocks. These are the Ordovician aged rocks, and they're in that kind of brownish, purplish, dark purple color near the top, spreading along the shoreline, the north shore of Manitoulin Island. And then we have a sequence of rock layers that basically go from what's called the Manitoulin dolostone layer up to Fossil Hill, and those are in the green. And then we have the iconic Niagara Escarpment rock. We have the Amabel dolostone formation, which is the pink, and that marks all along the shore and north into the interior of Manitoulin Island. So if I was doing this presentation pretty well anywhere else on the mainland, I would go through every rock layer that you have in your area. Obviously, if you saw that diagram earlier, I can't do that. There's just too many, but I want to show you a few iconic rock layers that you have that I've also explored on the mainland, and talk a little bit about the layers and the things that are found there. And I'm going to start with what the Georgian Bay Formation, which is the oldest layer. Like I said, or perhaps I alluded to, typically in the Niagara Escarpment, the Georgian Bay layer is not really considered Niagara Escarpment. It doesn't start to outcrop until roughly Owen Sound. And we get a little bit of it around Owen Sound, but then you don't get really all that much more. But in Manitoulin Island, you have a whole north shore of Georgian Bay Formation and older rocks, and like Gull River and Verulam and all these amazing old Ordovician layers. And what's lovely about the Ordovician era is that it's as my friend calls it, it's fossilicious. It has incredible array of fossils. The Ordovician was a time in Earth's history where the globe was covered with small little continents. So rather than all being grouped together, there were lots and lots of sort of island continents. And when you have lots and lots of little continental masses surrounded by water, you have a much more temperate climate. And so really the whole planet was just thriving with sea life. There was nothing on land yet, except maybe some primitive algae, but there was lots and lots of life in the seas, and some, giant cephalopods, big, squids that live in long shells. And we had trilobites and all kinds of fascinating creatures. Then what started to happen at the end of the Ordovician, so roughly, 450 million years ago, is those little bits of continents started to group together. They started to sort of glom together to create a larger continental mass. And when you have a larger continental mass that has, really large and well away from maritime influences, you get a very different climate. You get cold and dry. So think Saskatchewan in the winter compared to Great Britain in the winter, right? That's the difference that you have. You have a continental climate is much colder and harsher than when you have a lot of water around in maritime. So what happened was at the end of the Ordovician, it triggered about 5 million years of glaciation. And it killed a lot of the life. It was one of the biggest extinctions. It was not as big as the big Permian extinction, which wiped out 95% of all life on the planet, but it wiped out about 60% of all life on the planet. And that marked the end of the Ordovician and the start of the next period, which was the Silurian. And there's a lot less diversity and a lot less fossils to be found, but we will find some, not to worry. But I just really love the Ordovician, and I'm really excited about being up on Manitoulin Island to see the Ordovician. I live in Guelph. For me to get to the good fossils, I have to go quite a distance east to do that. So this picture is sort of typical Georgian Bay Formation. I didn't say Georgian Bay dolostone or limestone or shale. All of those things are in this formation. sometimes a formation only has one rock type and you can just say, oh, it's Amabel Dolostone or Amabel Formation, and it's interchangeable. With Georgian Bay, there's lots of stuff going on. So we'll just say Georgian Bay Formation. This has been taken on Colpoys Bay, and it's got some really lovely fossils. Now, this one is quite extraordinary. I showed this fossil to some friends of mine at the ROM and U of T. These are brittle stars that were found by a friend of a friend. And my friend has been given this. The other gentleman passed away, and he found it on Colpoys Bay near Big Bay. And this is one of the best examples. These are basically starfish. They are like 460 million years old. They're from a sea that we just couldn't even imagine, a world we couldn't even imagine. You know, the world was spinning faster then. We had about the same amount of oxygen, so we probably could have survived, but there was nothing on land. I mean, it just really, it boggles the mind. So this is a really particularly gorgeous fossil example. We've gone looking for another one of these. We probably will never find it now. Manitoulin, we may well find it, which would be great. Here's a cephalopod in the bigger picture. This is about a foot long, and this is basically a long cone. And at the end of it, and the opening would be sort of a squid-like creature, and it was quite a predator, and it would scoot around and grab what it could. Now, I have seen these on the shores of Colpoys Bay, where the Georgian Bay Formation outcrops, 6 to 8 inches long. This is about a foot long, but I know the islands off to the west side of Manitoulin Island, there are some very large cephalopods, like meter long, and even longer. So I think that's really exciting. That's just a sign of the incredible diversity of life in the Ordovician, because you rarely see a cephalopod on the Niagara Escarpment, on the Silurian rock, the little bit younger rock. It doesn't have nearly as many. In the little inset, that's a part of a trilobite, if you will. That's part of an Isotylus trilobite. It's actually, that piece there is about 1.5 inches long. It's only about half of the trilobite, but I was pretty excited to see it. So I thought I'd put it in there. And this was from the same layer, the Georgian Bay Formation. So a really exciting layer, one that's on Manitoulin Island, something I would really love to explore a little bit more. So I'm going to move into these green layers, and we've got a few layers in the green area. It's a pretty major unit, and we'll start with the Manitoulin Formation, which is a dolostone formation. Now, you might be wondering, why do they call it that? Rock layers are named for what's called type areas. So if somebody goes and studies a particular layer of rock in Manitoulin, or they say, wow, it's really fantastically exposed in Manitoulin Island, they're going to call it the Manitoulin Formation. Now, this is not on Manitoulin. This is on the Saugeen Bruce Peninsula at Rush Cove, but it's a really nice example of a layer that you know much better than I do, actually, on Manitoulin for sure. The Manitoulin Dolostone. I love it. It doesn't have a lot of fossils, but it's a lovely flat layer. It's very predictable. It's when you're hiking along, you're on the Manitoulin, you know you're not going to do too many ups and downs. It breaks apart in these beautiful slabs. It's quite a lovely layer. And I know that sounds really crazy, but I do have favorite rock layers. So this is another example of the Manitoulin. It's fairly thinly bedded. You can see there the beds are about maybe 2 inches thick, not much more than that, and they stack up. This rock layer was formed in a very stable lagoon type environment. It's very common to find. It is pretty much in the entire you find this layer from Hamilton all the way up to Manitoulin Island. It's a really a ubiquitous layer. It's a robust layer, shall we say. And it forms lots of little waterfalls on the Saugeen Bruce Peninsula, and there are lots of waterfalls, I know, in Manitoulin that flow over the Manitoulin Dolostone. Now, we have in southern Ontario, we have a layer directly beneath the Manitoulin called Queenston Shale. There's no Queenston Shale on Manitoulin Island, which is unfortunate, but you have other great layers. But what's important about that, actually, I'm just going to come back to that in 1 second. This is a diagram from the Beaver Valley near Newford or somewhat. This is a little waterfall. This was a property donated to the Bruce Trail Conservancy in 2013. And you can see the Manitoulin Dolostone is overlying a layer called the Queenston Shale. And shale is very soft, and it's typical these waterfalls will churn away at the softer stuff and then undercut what's above them, and the rock will fall off. And that's how I
lost.
got muted. Yeah, I got muted. Can every, I'll just pick up.
I fixed it, Beth. I
Just,
apologize. I was trying to mute a participant who was making noise. You're good.
not to worry. Not to worry, I'll keep an eye on it. So this is a waterfall. You've got two rock layers. And what's important about this is the yellow line. Because remember I said we had this Ordovician period where we had lots and lots of life, and then these glaciers came and it locked the planet up in ice, and we had a mass die-off. That yellow line represents that mass die-off. That line represents 444 million years ago, and that's when 60% of life on the planet went extinct. And it is the boundary between the Manitoulin Dolostone on top and the Ordovician rocks below. And so on Manitoulin, it's not Queenston Shale, it's a different rock, but that's okay. We can find other rocks below it and explore those and learn about those. So I'm just going to go up a little bit because there's a couple of diagrams that I missed that I think will be important. So we're back here at Rush Cove, and this is again Manitoulin Dolostone. A lovely layer. See how it's nice and chunky and breaks apart in big blocks. And you can see how the water has worn apart or worn away at the face of the cliff, and it's undercutting and causing rocks to fall off. This is actually a really important part of understanding the Niagara Escarpment, is why it forms the way it does. And it's because we have softer layers underneath hard layers, or we have weaker layers underneath stronger layers. If we had the same rock type, we would all just wear away evenly. But we have this undercutting that happens. It happens at waterfalls, it happens at shorelines. And what it does is undercuts the harder rock, it falls off, and we have basically the escarpment face is retreating. And it's a pretty important element of the Niagara Escarpment, is to understand that retreat is due to this undercutting, and it's due to the fact that we have different strengths of rock, hard, soft, and that kind of thing. So there we are back at our extinction line. So I have just a couple of examples of fossils. I found this fossil, this slab of rock in Hope Bay. I have a place at Hope Bay on the Saugeen Bruce Peninsula. And I just was transfixed by, I said there weren't a lot of fossils in the Manitoulin Dolostone, but this is a really terrific little complex of fossils that has created what I call my fossil sad face. And he looks a little bit sad, doesn't he? And I took this and I created a little, a little emoji almost years ago. But anyway, I don't do that. I've grown up since then, but in any event, I just love this fossil sad face. He's got basically, if you, and I'm going to talk a lot fossils here, so maybe you'll know this, maybe you won't, but it's a horn coral, which sort of forms almost like if you imagine a horn of plenty, and you're looking down the mouth of that. That's the circle. That's his head. And then he's got two little horn corals for eyes. One of them is bigger than the other one, so it's maybe sleepy or whatever. And then his mouth is a brachiopod, is a shell. A fossil shell. And you can look at this and go, well, that looks like it's man-made. This is 440 million years old. So I do love them dearly. Fossil sad face, he's around here somewhere. I usually take him on my road shows when I go out and show people fossils. So I'll bring him up to Manitoulin. Okay, so we're still in the green layers. We're not quite there yet. Cabot Head Shale is another layer you have on Manitoulin Island. It's great. What's important about it is that it's one of those layers that gets undercut and causes the layer above to fall. So there's lots of beautiful Cabot Head Shale at Cabot Head. Again, type area, it's named for Cabot Head. And those are the clay cliffs where it was named for. I have been there. It's stunning. This is very much like the Queenston Shale, the layer that you don't have on Manitoulin Island. But you do have this layer, and it's a lovely clay shale. People think of shale as being sort of a platey, hard material, but it's actually quite clay-like. What you're probably thinking more of is slate or a more consolidated shale, but this is really what it usually looks like. Okay, where are we now? Fossil Hill Dolostone. So this is the important part. This is my favorite rock layer because it's full of fossils, and what you can see, those little lumps that are just where I'm standing, are little brachiopods, and brachiopods are like a shelled creature. They would filter plankton and things like that, and this is just an absolutely chock full of little, basically dead brachiopods, brachiopod graveyard. But there are other fossils in the Fossil Hill Dolostone. So of course its type area is Fossil Hill. on Manitoulin Island, which is super exciting to me because now I'm with the Escarpment Biosphere Conservancy, and we have a lovely property there with a hiking trail, and I get to go the type area of the Fossil Hill Dolostone and check it out. So I'm very excited about that. Let me show you some of the fossils. Now these are from Owen Sound area, a lot of them, Saugeen Peninsula, that kind of thing. These are some of the brachiopods. They look like little indentations of birds' feet or something, but they're little shells, and we will no doubt find those. I have no doubt at all. This is called halicites, and halicites is also called chain coral. And chain coral, it looks like a chain from the top. This is a beautiful slab from the Kemble area of near Owen Sound. This is an even better picture, not so blurry, of halicites. It is correct that there's an S on the end of it. It doesn't mean it's plural. That's the name of the fossil. And this is a really lovely one to find, halicite. Sometimes you see it it's sort of flush with the surface of the rock. Other times it's almost like it's been etched. And the reason it's been etched is that as this fossil develops, it's picking up silica, and it's becoming even harder than the host rock around it. That whole host rock is dissolving away and leaving behind this lovely, lovely fossil. This is Syringipora. It's also called organ pipe coral, and you can see it's like little tubes all over. This is stromatoporoid. It's a sponge. And this is important because the silica that was part of these sponges and a sponge is an animal. It's an actual animal in this wonderful Silurian sea. The sponges would consolidate, and if you had enough of enough compression, and over time you'd create a little nodule of silica. Silica is also called chert or flint, and this layer was actually quarried, if you will, in the Beaver Valley area by Indigenous people very soon after the glaciers left the area about 12,000 years ago. They actually have a site there where it was actively being quarried, napped, and they were traded all over the Great Lakes Basin from this layer of rock. That's a sponge. That's a whole sponge. You can see the layers of it. It's like a little bit of, it's like cabbage leaves on top of each other. I was really quite surprised to find this. It was loose. I did not take it. I'm trying to be, I say fossil collector. I should change that on my bio. I do have some fossils in my collection for educational purposes, but I'm a leave it there for the next person to find philosophy now. This is a lovely, we're going back to the organ pipe coral. I found this on a property that the Bruce Trail Conservancy owns. I bought it. This was some years ago now. And it's just a beautiful museum quality sample of Syringipora or organ pipe coral. All of these are extinct now, by the way. They're all extinct. Here's another one that's one of my favorite, the favicites or honeycomb coral. And it looks just like a honeycomb. And you know, you could put this next to a picture of a honeycomb, and it'd be quite remarkable because it looks so much like it. I've got lots of favicites because I'm just really in love with the favicites fossil. You can see it comes in different forms. So we're now getting to the pink layer, which is the Amabel Dolostone, the cap rock of the Niagara Escarpment, and the iconic for Bruce Trail hikers or people who visit the escarpment a lot. It's sort of the iconic rock. Here it is in the Beaver Valley, and lovely thick white layer of dolostone. Now, do you remember I showed you the Manitoulin dolostone, and we just saw the Fossil Hill dolostone, and they were formed in very sort of passive lagoons, not much going on. Everything was pretty calm and quiet, nice flat layers. But by the time the Amabel dolostone was being formed, that drawdown was happening even more actively, and the corals were having to reach up to get to the sun to continue growing. And so they started to develop these reefal mounds. As opposed to just being flat, they started to sort of group together and go up in these mounds, forming what's called pinnacle reefs. So you get a lot more undulation of that cap rock layer than you do, for example, on the Manitoulin or the Fossil Hill. Again, like I said, you know, you have a nice flat time on those layers, but the Amabel can be quite up and down. Here it is on at Cup and Saucer at Manitoulin Island, Michigawadanong. I'm really trying to learn the Indigenous names. A lovely, lovely area, and I can't wait to see it because I have never been there. So, oops. Mount Nemo down near Burlington, again, thick white iconic dolostone. Not a lot of fossils in the Amabel dolostone. It's very heavily dolomitized. It's been altered a lot through that process of going from limestone to dolostone. But there are some fossils you can find. And here's one. Crinoid stems are quite commonly found. Here's some stems in a drill core of Amabel dolostone. And there's a piece I found right on the Bruce Trail full of crinoid fossils. So Escarpment Biosphere Conservancy, the organization I am delighted to be working for and serving now, owns, has acquired, preserved, owns land all over the Escarpment and Saugeen Bruce Peninsula and Manitoulin Island. And, you know, we really do fine work. There's a couple of my staff members at least are on this call, which is really delightful. Thanks, guys. But I want to focus in on one particular property, and that is, oh, sorry, before I get there, here's the other book I'd have in my back pocket. If I had the geology book that's done by Peter Russell and his colleagues, I'd have this book as well. And this is a book that was created by Amy Darrell, who I think is on the call still. And it's hikes that you can do on Manitoulin Island. And it's a great book, terrific book. And here's a map showing where those hikes are. And number 9 is the one that really charms me, because this is Fossil Hill on Manitoulin Island. So here is my, well, let's have a look here. We have a map. Yeah, so we have a map off Highway 6. You can go in, we can hike for not too long. I always find my hikes are very slow because we're always looking at fossils and looking at the rock formations. But basically what I'd like to do is invite you to come out with me sometime this spring. I don't know when. I'm going to work with your people to find a good date that will work for your club, or maybe it's even in the summer, but the spring would be nice before the leaves are out too much. And we'll go for a fossil walk on Fossil Hill, at Fossil Hill, and see what we can find, and you can help me explore your island. And I'd really, really look forward to that. And that is the end of my presentation. Thank you so much.
Can you pop again? Can you pop again? Because I was wrong. Oh. I want them to hear the clapping.
Oh, is there clapping? No. I went through that pretty fast. There's a lot more that I could discuss, and I really look forward to it, because I need to get my head around Manitoulin because it's complicated. And always my task is to explain things in a way that people can grasp it and really digest it. So I'll get there, and maybe you guys can help me this spring sometime.
Well, I certainly think you accomplished that today, explaining it. I mean, there was a lot of information, but I think we learned a lot. And I'm thrilled to say that we have 17 people in the room and 25 people on Zoom, which is really great for our club. We have 150 members, but you know how it goes.
Well, thank you.
I'm sure there will be lots of questions, if you're okay with that. To do.
Oh yeah, absolutely.
So please feel free to unmute yourself, and anybody in the room, please ask away. Did we turn one light on maybe? Oh, yeah, just through those doors. I was really impressed about the caribou migration.
Oh, yeah.
Can you tell us a little bit more about that?
You know what? I'm straying out of comfort zone because I am very much a geologist, but I do know that the area of between Kelso and Hilton Falls, where the 401 basically goes through the Niagara Escarpment, is an area that was identified as a caribou migration route, and not that far away was an Iroquois village. It's now been recreated as Crawford Lake, and there's a longhouse there and that. But there was a very strong Indigenous presence there, and this was an area that one of the reasons that they settled in that area was because this was a migration route through the escarpment. The escarpment is you know, it's not like a mountain, but it is an impediment, right? So you have certain channels where animals will migrate, and this would be, you know, not long after glaciers retreated, so about maybe 11,000 years ago, 10,000 years ago, we had a subarctic climate. We had caribou. We had all kinds of things we don't have nowadays in a very cold climate. And that would be, and they would be hunting in that area and finding these channels that go through the escarpment where the animals will have to sort of funnel through, right? And finding places to hunt them. I wish I knew more, and I really wish I knew the perspective from an Indigenous perspective as well. It's something that I should explore as well and find out more about that and about the stories around that time.
That's very fascinating. I have a question online here. Is it erosion that causes the gaps in the escarpment as you move north and around the Michigan basin?
Yeah, the escarpment is a product of erosion. There's all kinds of myths out there that it's, you know, a tectonic fault and things like that, but it's not. It's simply a bunch of layers of rock of different hardnesses and softnesses, different strengths that are being worn away in different ways. Now, we did have a period of time as the glaciers were melting, I would say about, well, they were sort of leaving the area about 12,000 years ago. And they were melting back towards the northeast, and coming off the front of those glaciers was massive, massive amount of meltwater. Now, the glaciers themselves did not carve the Niagara Escarpment, and that's another myth that is out there, that it's a product of glacial carving or what have you. But the glacial meltwater really, really did a number on the escarpment face. So where you have these surges of meltwater, you've got very cold water, and very strangely, carbonate rock like limestone and dolostone is more soluble in cold waters. That's one factor. The other is that this meltwater is full of cobbles and rocks and boulders and sand, what have you, from the Canadian Shield, which is much, much harder than the local dolostone and shale rock of the escarpment. So as it's surging through, it's creating these incredible channels. And if you look at the Saugeen Bruce Peninsula, and I think it's the same with Manitoulin Island as well, you get these sort of like stripes almost, or you can see the direction of that meltwater because it was surging through. And of course, if it can find a channel to go at, the water will all concentrate there. So you get this uneven erosion of the escarpment. It was interesting too, is that about 8,000 years ago, so we had all this meltwater coming off the glaciers. Glaciers are melting back to the northeast. And then about 8,000 years ago, the land in front of the glacier had rebounded sufficiently that it cut off the water going into the Great Lakes. And all that water went down the Ottawa Valley. Suddenly, the Great Lakes almost dried up. So we had a small lake in Lake Huron, a small lake in Georgian Bay, and a big river that connected them. And I had this conversation, or I was talking about this with somebody at Parks Canada many years ago, about 2006 now. And Lenore Kishik-Tobias, who's from Cape Croker area on the Saugeen Bruce Peninsula, she said, oh, yes, my ancestors have a story of walking, or my people have a story of our ancestors walking to Manitoulin Island. And they could have done that 8,000 years ago. And they have artifacts from this river that was passing by Tobermory 8,000 years ago. It's 150 feet underwater now, but it wasn't then. So lots of ups and downs of the Great Lakes, but the meltwater off the glaciers really did carve into it. I'm getting back to the original question. Did a lot of carving of the escarpment face, yes.
This is fascinating.
More questions? Yeah, please.
Hi, Beth, Lori here. Thank you so much for taking our invitation to speak. We really appreciate it. I think Ted Cowan is here as well. So is he?
Yes, I see he is, and I've got some staff.
Hi,
I'm
Ted.
delighted. I'm delighted.
Beth, my question is, you said about the die-off at the end of the irrigation. Can you explain what caused that?
Yeah, so it was basically that drop in temperature, right? So when you have a massive drop in temperature, so the little islands of continents that were nice and warm and had nice high water levels started to group together, and the earth got colder because you now had a continental climate. And we started to get these colder land masses, and because it was colder, we had more ice developing, which lowered the water level, which made it harder for the species to survive. Their water got colder, they had less space, and eventually they died off. Yeah, that's what caused that extinction. It was that drastic cold and which changed the water level, changed a whole bunch of things in their habitat.
Just a question on that. How many years ago did that happen?
444 million years ago is the end of that period. So probably about 450 million years ago that whole process started. Yeah.
Go ahead, Lori.
Long time ago, and you can still make plans for the weekend. Nothing like that's going to happen for a while. So.
That was my question. I just wondered how the time frame for it.
Okay, thank you. Okay.
Yeah, long time. See, here's something. Can I just tell you about time frames? Because I think this is something that people really have a hard time grasping. How long ago is 450 million years, right?
Yeah,
So if you extend your arm out, I'm going to watch the people in the room. I want you all to put your right arm out to beside you, okay? And follow along. Your shoulder is when the Earth was first created about 4.6 billion years ago. Our escarpment wasn't created until roughly the knuckle of your middle finger.
Oh my God.
Your finger.
the middle.
The dinosaurs died out. The dinosaurs died out at the base of your fingernail, right? The base of your fingernails when the dinosaurs died out. They're way younger than the escarpment. And you could erase all of humanity with one swipe of a fingernail.
Yeah.
So these concepts of time are too big for us to comprehend. But we can try. They're majestic. They really are.
No kidding. I have another question in the room here, Mary Alice.
You started down my work there. That's not part of the yet.
Did you hear that, Beth?
I'm sorry, I didn't catch that. No, I didn't. I'm sorry.
The escarpment at North Bay, that's not part of the Niagara escarpment?
No,
Okay.
definitely not.
Okay.
Yeah.
Anybody else?
I'm intrigued, but it's not an escarpment. It's not Niagara escarpment.